Hello everyone, I'm Shuhuai, the UG coordinator of the Department of Mechanical and Aerospace Engineering at Hong Kong UST. Now, I'm very happy to introduce our department and the two undergraduate program, Mechanical Engineering and Aerospace Engineering to you. We hope this video will be useful for the high school students who are applying for university and the newly admitted university students. What is mechanical engineering? Mechanical engineering applies the sciences of mathematics, physics, materials to design, analyze, manufacture, and maintain mechanical systems. In Hong Kong UST, we also extend mechanical engineering to aerospace and aeronautics engineering. Broad industrial sectors are covered by mechanical and aerospace engineering, including transportation systems by air, by sea, by land, energy systems, traditional power generation systems, now the new renewable and sustainable energy systems, building and infrastructures, design, manufacturing are the traditional industries for mechanical engineering. And then the aerospace and the airline flight systems. So let's actually first look at what are the career paths of our students who graduated from our programs. So including like the transportation system we mentioned first. So our students will follow, after graduate, will follow the aircraft engineering developer schemes. So the internship offered by airline companies like Boeing, and also the Air Cassette Corps. And after these trainings, they can become aircraft engineers, maintenance engineers, and some become pilots. So for the land transportations, in Hong Kong, we really rely on the ground transportation like bus systems and MTR subway systems. So our students will work as a railway engineers, maintenance engineer, and also do the management work. So also the Marine Department also hire our graduate students to work on the boat, becomes captains. Energy systems will have our traditional power generation systems to hire our students. For example, the CLP, China Gas, Hong Kong electrical companies will all hire our students as engineers or for the management work. And then the new energy systems, renewable energy systems like using solar, wind, biomass. For example, the power plant station in Lantau Island, we actually have the new wind power power generation company. So energy system actually also include new products like LED and the electrical cars, new types of batteries, fuel cells, etc. And so they are very important in the building engineering systems and the transportation systems. So our students will also work in the government for the energy management and energy auditing. So we will have a lot of students working closely with the government for the energy policies. Building engineering, building maintenance, infrastructure are very important in Hong Kong. So for example, like the heating, venting, air conditioning systems all requires mechanical engineering subjects. So our students actually works in those consulting companies for constructions and for maintenance and also repair systems. As mentioned, the design and the manufacturing, although not very popular in Hong Kong, But we do have many companies working on electronics packaging system, automation system, and robots, sensors, machines. So here are just some examples, some big companies who are hiring our students. So for aerospace industry, students are working for the power propulsion systems, aircraft designs, aircraft maintenance. So those are a few samples to show like the possible systems and the companies who will actually hire our graduate students. So this is actually a summary of our UG graduates just graduated last year. Class of 2018 in the, from the aerospace engineering. So 2/3 of students actually work in the engineering and the industries. Some are actually moving to the business, commerce sectors. Next slide is actually the distribution of the undergraduate graduates of class 2018 from mechanical engineering. So we have more students from mechanical engineering. A majority are actually working for the engineering and industries. So some of the company employee names are listed for you. Now we will talk a bit about our department. So we are actually looking forward to. So let's do it again. Okay. Yeah. Let's do it again. Now let's talk a bit about our department. Our mission is to produce high-quality ME and AE graduates with a global look and all-round capability. We are also nurturing researchers with global look and leadership. And our learning environment provides outcome-based education, taught postgraduate programs, graduate programs for researchers. So we are taking the stakeholders like our faculty, staff, and students with care and sharing and innovation spirit. So we are valuing research excellence, internationalization, innovation, and entrepreneurship. So currently in the department, we have 33 faculty members, all from leading universities worldwide. So here showing the university of the home schools of these faculty members. So recent QS World University ranking, we are very proud to achieve number 18 in engineering and technology category. So by subject, also in the engineering and the technology subject, in mechanical, aeronautical, manufacturing engineering, we rank 29 worldwide. Also the first in Hong Kong this year. Now let me actually go through the curriculum of the two programs. So this is the curriculum slides for the mechanical engineering program. So this is a very busy slide. Let me just walk you through. So from the bottom, so if you can read through from the bottom line. So once the student come to Hong Kong UST, they are admitted by school. So the university actually requires university common core courses. Then in their first year, the students are also required to take the engineering fundamentals, which include roughly like 8 courses. So covers mathematics, physics, so 1 science course, 1 engineering course, 1 language course, and 1 computer science or computer language course. So from the second year on, after their major selection, if they are coming to our program, the students will take the mechanical fundamentals, which include 6 courses listed here. Then following on, we will have a mechanical core course and electives. So elective courses are divided into three directions in energy, materials, and design. So for students who would like to go on graduate school, they also would like to try the research options. So for graduation, the minimum requirement is 120 credits. So here we show a few passes for your consideration for graduation. So you can take 109 credits from these fundamental courses and required courses, then leave 11 free credits for you to choose. You can also choose mechanical options with like each option will be in-depth option will have 3 courses for each direction. Then leave you 2 free credits for your free electives. Then you can also choose to take 2 mechan options, or you can choose do even minor or double major. So double major means you can do 1 major in mechanical engineering and maybe 1 major in other department in engineering school as well as in science school. So minor, I will show you later, like from mechanical engineering, we offer minors. From school and engineering, we offer have other minor programs for you to consider. So the following are list of the courses for you to just check. So that's a complete list of the course, which include like the required course and option courses. So similarly, we have the curriculum for the aerospace engineering, which also has a similar structure, including university common core courses and the engineering fundamental courses. So instead of mechanical fundamental courses and required course, AE program has their own fundamental courses and the required courses and the elective courses. So as listed here. So we also have the research options for those who aim for graduate school. So the total credits is all for all these courses are almost like 120, but there's no like rooms for minor. So if you want to take minor programs, you will take more credits. So these are the list of the courses for the AE program, AE curriculum. Now comes to the minor programs offered by School of Engineering. So currently, School of Engineering offers nine minor programs. MAE actually offers the Aeronautic Engineering program. So as you compare these newly established program, we have actually similar qualification requirement and a similar creditor requirement. So most of the minor programs requires 6 courses for 18 credits. But we do have a minimum requirement of your CGA in your previous study of 2.5 is the minimum requirement to be admitted for the minor program. So the minor program requires 3 out of this list as a required course and 3 out of this list as an elective course. Industry training is one of the signature program in our curriculum. So hope through this industry training, our students will have a broad and structured understanding of engineering practice. So this will also help the student to fulfill the requirement from Hong Kong IE. So currently, there's 3 modules, including like 1 from PolyU and 2 modules in-house. In total, it takes about 6.5 weeks. And so next, I will show you 2 videos that actually gives you idea the requirement for the final year design project. So this is one taken in 2017. Actually, this project also wins the Hong Kong UST President Cup and the ASM Technology Award in that year. So it is about a smart, soft, and effector robotics, you can think.
Today, we're here to introduce an undergraduate student's research project, which is called the Smart Soft End Effector. The objective of this project is to build a smart soft gripper that provides an adaptive grasping motion to objects with different shapes and sizes. Current robotic grippers in the market have a lot of disadvantages. For example, in order to achieve a delicate grasping motion, such as grasping an egg or other fragile objects, it is very expensive, complicated, and time-consuming to develop a working system. This is also confirmed by the industry through our connections. Herein, we propose a novel, low-cost, soft robotic gripper integrated with a set of flexible sensors, which we call a Smart Soft End Effector. The Smart Soft End Effector consists of an adjustable base that provides changeable grasping range and configurations to serve different kinds of objects. Soft and adaptive fingers that are just like our human fingers. Each finger is powered by compressed air. When air enters the fingers, chambers will expand, bend the fingers, thus creates a stable grasping motion. Bending sensors and pressure sensors are integrated into different locations of the soft finger. They collect grasping information for a more precise control. The entire system is governed by a program that controls the bending angle of the finger and the grasping force. The design and manufacturing process is collaborated by the entire team. Before actual manufacturing of the real prototype, our team members will use computer-aided design software to visualize the design. And this helps us find out the potential flaws and improve the structure. Then we use simulation programs to estimate the pressure distribution on the finger and predict its motion. At the meantime, team members will start coding the controlling program for the system. We use silicon rubber as the casting material of the soft fingers. Silicon rubber is a non-toxic, flexible, and low-cost material. It minimizes the physical damage during interactions. The result of the project was really satisfying. The gripper is able to handle objects of different shapes and sizes. Through closed-loop control based on the pressure sensor, a delicate gripping force control is achieved. Even more surprisingly, the gripper is dexterous enough to handle a piece of tofu without damaging it. With the adaptiveness of the soft gripper, objects of different shapes and sizes can be sorted and packed for delivery automatically. Soft machines can also be a future bridge of human-machine interaction due to its soft nature. We believe that the Smart Soft End Effector can even be used in fields of higher purposes, like medical services and rescue missions, that will bring hope and benefits to more people.
Next video is actually about a UAV with a vertical takeoff and a horizontal cruising capability done by aerospace engineering students for the final year design project.
Final Year Design Project 咧，又叫 FYDP， 咁咧係我哋每個 MECH 同學咧 Final Year 都要做嘅一個 project 嚟嘅。 咁今年咧，我哋嘅題目咧係設計一架可以垂直起飛，然之後喺半空中切換到水平巡航模式嘅無人飛機。咁類似嘅概念咧，其實喺美軍嘅魚鷹運輸機啦，同埋 F-35戰鬥機當中咧都有採用。咁但係咧喺無人機領域當中咧，就仲未有好成熟嘅產品。咁所以咧，我哋想透過今次 FYDP 咧嚟去填補呢個市場上嘅空白。飛機嘅飛行原理咧就主要分兩個部分。當飛機垂直起飛嘅時候咧，4個摩打咧就會提供向下嘅推力，由令到飛機可以垂直咁樣起飛。由當飛機飛到一定高度嘅時候咧，我哋就會將摩打轉90度，咁樣咧佢哋就會提供呢個水平嘅加速度俾飛機。由當飛機達到一定速度嘅時候咧，氣流喺機翼嘅表面咧產生嘅升力咧，就使飛機咧可以維持喺飛行嘅狀態。由成個過程咧，都係由飛機上面嘅微型控制電腦去控制嘅。咁佢會控制4個摩打嘅轉速啦，同埋角度，由使到咧飛機咧會有一個平穩嘅姿態。設計同製作係團隊合作嘅過程。咁喺實際製作之前咧，我哋嘅隊員咧會先用電腦輔助設計軟件咧去設計呢架飛機。喺電腦裏邊先將飛機畫出嚟咧，可以令我哋更容易咁發現飛機潛在嘅問題。然後咧，我哋會將呢個電腦模型啦，用專門嘅空氣動力學軟件進行模擬實驗，觀察佢空氣動力學性能可唔可以達到預期。我哋都會同時進行微型處理器嘅程序同埋控制方法嘅設計。製作嘅時候咧，我哋都用咗好多唔同嘅方法，例如為咗更快地做出試驗飛機，我哋會直接用發泡膠做出機身，然後用玻璃纖維包裹發泡膠，使到呢個發泡膠更加堅硬。我哋仲利用咗比較輕而且硬嘅碳纖維材料去做機身嘅主結構，咁樣咧就可以使機身達到強度嘅要求，同時具有呢個比較輕嘅重量。咁喺飛行試驗之前咧，我哋會做好最後嘅檢查，例如睇下呢個螺旋槳嘅方向有冇錯啦，摩打有冇固定好啦，同埋呢個微型處理器嘅工作狀態係咪正常。咁然後我哋咧都會觀察周圍嘅環境，睇下會唔會影響到其他人。咁飛行試驗嘅結果咧就十分令人滿意，佢可以好平穩咁樣垂直起飛，之後咧好安全咁樣咧轉換到水平巡航嘅狀態。咁喺未來咧，我哋會繼續改善我哋嘅設計，例如話咧將中間呢個負載艙咧分散到兩邊，咁樣咧就使呢個飛機可以攜帶更多嘅重量。未來咧呢架飛機嘅應用前景咧都好廣闊嘅，我哋可以用佢嚟探測森林火災嘅源頭啦，或者喺農業當中咧，我哋可以用佢嚟噴灑農藥。利用無人機咧就代替人咧去從事呢啲危險嘅工作咧，就會令到呢啲工作咧就變得更加安全啦。
For our student final year graduation requirement, so instead of doing the final year design project, FYDP, we also offer the co-op program to give the students opportunity to work in a real setting in the company. Each year in the spring semester, the students who selected this program will spend 5 months to work in a company in local or mainland China or overseas. So each year we have about like 1/3 of students join this program. So here showing some partners, companies from different sectors, and the students who actually selecting those companies, the examples. Each year we have around like 35 students who will join this program. So it's also very welcomed by our students, also by our future employer companies. MAE also have the new internship programs, which actually last a bit longer than the co-op program, half-year to 1-year program. So currently, we have a few companies who actually offers us this opportunity, including some major companies in the airline industry and the transportation systems and electrical power generation systems. So a few students will work 1 year there and take like a gap year to do this internship and come back to finish the program. We also have overseas exchange program, although this is actually coordinated by the School of Engineering. Each year we have students from other universities from all over the world. Then we also have our own students sending to these universities. So here are some universities in mainland China as well. So the exchange out students will be like 30 students each year, roughly. So this year, students can either take to choose to take the exchange program in fall semester, in spring semester, also summer will be also another option. So we are very happy MA students now receive more and more support from the industries as well as the government. So we have many scholarships specially designed for the MAE students. So in this year, just the past year, we have like many students receive such a scholarship. Some are especially designed for aerospace engineering, some are for like power industries and environmental energy industries. So lastly, I would like to take this opportunity to showcase the achievement and the extracurricular activities of our students. The first one is the ICON 2019. The student made table tennis robots in this competition and won the first prize. And the American Institute of Aeronautics and Astronautics hold the annual Design Build Flight competition. And this year was in Tucson, Arizona. So our student actually took this trip to Arizona. And the student branch of AIAA also organized a tour in Seattle, have an aviation tour, visit the Boeing airplane facility in Seattle. Our team also joined the international micro air vehicle competition this year. And they actually experienced their vehicle actually have the experience in outdoor events, like they can mapping, identifying objects, and detection, searching, rescue missions, and indoor they can also detect obstacles, read signs, and fly through confined space and adhere to smooth sidewalk. Very interesting development of these skills. So this one is actually a joint effort with other universities like the Dextron University, the HKUST, IMIT in Australia, and UPenn. They hold the annual revolutionary aerospace system concept hosted by NASA. And they actually experienced in-space transportation this year, and had the experience on the lunar system. So they actually designed this theme and help the student to have a flavor to explore and detect the water on the moon and extract and transport ice back to the station. Also very interesting experience to me. So we also have a virtual international project team with Iowa and UAM from France. So we actually collaborated with students over there to have some joint projects. So lastly, I would like to mention this aviation scholarship actually newly created just to promote the aerospace program. So this is actually sponsored by the government, and we are lucky each year we have several students to have this very prestigious award. So with like 100K Hong Kong dollar for each student to sponsor their education in this AE program. So we actually value our alumni, and our alumni is the precious asset. So each year around November, we will have the homecoming day. So on that day, we host the students of like recent graduates, or some actually really like really senior graduates to come back to campus to enjoy some sports activities and enjoy gathering together. So these are some of the pictures. As you can see, we have many. So the family is actually glowing. So we sincerely wish like you will join this happy family. Thank you very much.